started, I think some of you have already introduced yourself, but I'm going to be a little bit different this time round. So introduce yourself, but I want you to also tell the audience one sort of set of tasks that was space tech related last week. So don't just talk about your job title and who you work for. Tell the audience, what were you doing this time last week? Over to you, Francesco. You can also make it up, sir, but...
I can make it up.
What were you doing this time last week?
Very interesting question. I think that I was reading a book, and I was reading a book related to financials.
Very good, very good.
Okay, so I feel a bit of an interloper here because I know very little about satellite communications. However, Wysun does deploy a very large number of IoT nodes, some of which use satellite. So I'm Phil Beecher, by the way. What was I doing last week? I was in a panel discussion in Austin, Texas, with Silicon Labs, who provide radio and edge computing for large-scale IoT, amongst other things.
Very good, Phil. You can be our sort of proto-customer for
yeah, that's exactly what I am, I think.
Very good. Okay, last but not least, Phil, Matthew.
Yeah, so whilst obviously respecting confidentiality with my clients and the work I do, this time last week I was fortunate enough to be in a multilateral discussion virtually with some key regulators in the Middle East region towards forging some harmonization around, as it happens, communications technologies, of which satellite IoT was one of them.
Very good, thank you. Okay, so Francesco, can let's get the ball rolling. In terms of, you've seen a couple of presentations from market research analysts. Can you perhaps, from your point of view, what are some of the major investment trends you're seeing in the space tech industry, especially if there's anything you sort of pull out relating to satellite comms and sort of satellite IoT?
Well, because of my experience, I lived IoT in satellite using geosatellites. And I should say that I've seen people making money out of IoT using geosatellites in South America. And in my commercial role, I tried to sell IoT in other regions and it didn't work. Why? Because we were talking about the big latency. So I think that today, and I have to say that we invested at that time in the company where I used to work, a lot of money to develop LMBs, which were able to transmit 9.6 kilobits through a small dish. So if you ask me, when I look at this audience, I think that because of LEO and MEO satellites arriving, we see that there's a lot of, I would say, energy to develop new systems to cope with this integration of non-terrestrial networks and terrestrial networks. We discussed before on the panel of 5G and all the different frequencies. So I see a lot of energy in that sense. I see all these nice terminals which are coming on board, which should facilitate our work. When I look at the numbers, I see the numbers are there. I think they are quite optimistic, not because I want to criticize the research, but before people adopt, they want to see. And the problem you have is that for doing what we have to do, we need, again, money, and that money doesn't come from financial investors unless they don't see some return in what they're putting on the table.
Yeah, you mentioned in terms of sort of the business model for some of these sort of scenarios. I mean, you see that as being a challenge, because there's a lot of interest in that. Can you elaborate a bit more on what you think some of the business model could be?
Looking at the transportation, if I remember well, a few years ago we had Qualcomm, which used to transmit small messages by satellite, and they were on the trucks. They were immediately replaced by our famous smartphones, and we saw this business which was running at multi-million per year, going to zero in 2 to 3 years. Why? Because satellite requires an antenna. This antenna requires a professional installation. At that time, the cost of these antennas were around $20,000 to $30,000. And they've been used also during the Iraqi war. And they were heavily used. So I think that transportation is going to be a big challenge because today, unless you're in remote areas where there's no infrastructure, you have connection almost everywhere. So I listened to you about Scotland.
Yeah.
I can tell you, as soon as you get out of France and you do 200 kilometers, you're on 3G and you have no more internet. So I don't know what Orange is doing. If we have people from Orange here, I would like them to install some antennas in this region.
Yeah.
So this is a big challenge. Then, to be honest, I tried to sell IoT because I think I was very smart doing that to shipping companies. And I said, what about all these boats, cargoes which are going across the ocean? You know what? I discovered that these have a local terrestrial network, a local network on the ship, which is communicating through Starlink back into a POP, which is then transmitting the information in real time. So also there I failed miserably, to be honest. I remember I was in Madrid, and I failed selling this idea to somebody. So where I see a good impact will be in agriculture, because you need to have very high precision systems, and I don't think that today local mobile operators or telcos will install many antennas in rural areas to allow very precise, I would say, farming. So this is where it can work. I know of a customer which has something like 5,000 cattle in Argentina. Each of them has a small chip, and he knows exactly where these cattle are. So this is a kind of application which works, a rural area, and where the demand could be, let's say, requiring high precision.
Very good. Okay, well, let's come back a bit more to the discussion about some of the business model. I want to try and bring the rest of the panel into the discussion here. But I appreciate that, Francesco. So Phil, I mean, perhaps you can elaborate a bit on the Wyson Alliance. I think people might not know who you represent and what does Wyson do.
Yep, so mostly we are providing interoperable, large-scale outdoor wireless mesh technology, so providing high reliability, very good coverage, smart meter networks, smart city networks. So if you happen to be in the City of London, look at the street lighting network, the illumination of St. Paul's Cathedral, that is using a wireless mesh network. So most of it is city-based, but where satellite gets interesting for us is, as you just described, agriculture. So, for example, maple syrup farming, believe it or not, in Canada, no cell phone coverage there. IoT devices are powered by solar and battery support, and they're basically monitoring the amount of maple syrup that comes out, if there are any leaks in the pipes, when the containers get full. So the actual data transmission through the satellite is quite small, unless there are errors. Another one is community solar. So we have a member company that is providing solar electricity generation into villages in Cambodia, Nigeria. They've just started doing Africa, so no cell phone coverage there. And then the IoT is used for solar management, fault and diagnostics and billing data. So that's the sort of place where it really is useful to our members.
Right, so you're sort of using a satellite gateway and then using the Wyson, could you be using the Wyson?
So it's effectively a wireless mesh local area network that connects through a border router into a cloud service somewhere. And typically in a city, that's through cellular or fiber.
Right.
But when you go remote, it's satellite.
What about in terms of the cost of the service? I mean, in terms of that backhaul link, I mean, is that viable for your customers?
If it's cheap enough, yes.
I know ones are cheaper, but is it the price is right now?
It depends on, I mean, again, if you're paying per byte of data, you want to minimize those costs, particularly in the community solar type environment where you're looking at low cost because you're talking about fairly poor communities. Believe it or not, the maple syrup industry makes a fair amount of money, so they can support that.
So,
And as you pointed out, livestock management is another area as well.
right. All those pancakes that have been consumed in North America, I think, sort of drives the economy there.
Exactly.
Let's bring in Matthew now. So, what did you, I think just elaborate a bit more on what your company does. I think very much delve into licensing and spectrum. Is that the case?
Yeah, so River Advisors are a global consultancy specializing in international regulatory and licensing matters, which includes a significant spectrum component. In fact, we were originally set up as a company called Mansat, who had a public-private relationship with the UK Ofcom in order to get satellite operators filings through to the ITU. Since then, in recent years, we've branched out our capabilities to provide market access as well. So what we're looking to really do is provide a fully end-to-end regulatory solutions to predominantly startups who want to get to space, not only through lodging frequency filings with the ITU, but actually getting to markets around the world and being able to deliver their services in compliance with local regulations. And that's where I step in. And so I help clients interact with the national regulators, get their foot in the door and help them understand the roadmaps and the obligations they need to comply with. And as we'll discuss, I'm sure in the area of spectrum, it's becoming very much a national game, not only an international game at the ITU. So it's a very fascinating area to be involved in at the moment.
I mean, we're sort of in between the World Radio Congress type initiatives. Next one's 2027. IoT largely needs, L and S band and so forth. What are some of your concerns, your customers, about access to the spectrum? Do they need more? Is it about getting access in particular countries? What's keeping you busy?
Yes, absolutely. As you presented, the proliferation of LEO constellations and the billions of devices that we're seeing in IoT means that there is an increase in demand for spectrum in the area of IoT. And the nature of that spectrum in the LNS means that it's competed for by other services like direct-to-device and also IMT as well. So it's about enabling regulators and governments to realize the value of satellite IoT for their local economies and digital transformation. And in fact, there's been a lot of national WSC cycles are every 4 years, which obviously technology can't wait for. And there's been a lot of national progress in between then. So citing some like Australia and Saudi Arabia, both those countries have vacated spectrum in the S-band fairly recently for narrowband IoT. And in Europe generally, we're also seeing the Radio Spectrum Policy Group highlighting satellite IoT as a prime area for the S-band spectrum post-2027 when that becomes available. So the very encouraging thing is for people in this room is that satellite IoT is firmly on the agenda of national regulators, but also regional bodies in the ITU. And just to finish with the WRC, there are some very relevant agenda items on the agenda for WRC for IoT. One is agenda item 1.12, which deals with low bit rate devices in the sweet spot between 1.4 and 2 gigahertz, which offers excellent propagation and low power benefits. And that is hopefully going to be transformative if that goes ahead in getting the harmonization among administrations in terms of technical sharing with other incumbents. So that's really an agenda item to look out for in 2 years' time.
And then, so in terms of World Radio Congress 2027, so you're going to see it as a bit more of a win for the satellite community? I mean, there's the cellular community, and even though some of the other wireless technologies all competing for access to the spectrum, but you think the interest, the stakeholders within satellite community will be assured?
Yeah, absolutely. And 1.12 is only one of several items dealing with satellite. There's also one dealing with the more the NTN direct to cell, and also gateways, spectrum, QV bands, for example. So it may in fact be the case that 27 sees more satellite-related spectrum topics, which is really excellent for the ecosystem.
Francesco, do you share that view?
Yes, I do share that view because I see that if we take the example of the C-band in the United States, they had to buy that frequencies in order to expand the terrestrial network. And in Europe, something similar has been done, but there's been no compensation. And I'm thinking about other countries, other regions where this might happen. So I think that in the WRC, we need to make sure that the satellite community is protected, because if not, we're going to disappear. And we're going to be forced to use more and more this, what we said early on about these high frequencies, which certainly can work, but will require huge investment. And who's going to pay for that?
Right. Very, I see. Phil, perhaps, in terms of interoperability, I mean, how important has that been in sort of low-powered sort of networks?
Traditionally, talking about the LPWA, not so important, but it's coming much more important. So with YSUN, we've always used IP protocols, IPv6, which gives you enough address space for a very large number of IoT devices. You mentioned LoRa earlier. LoRa has worked on that effort as well, so you can run IPv6 over LoRaWAN. And I think, so it's important that I think there's no one-size-fits-all for networking technology for communications. So you're going to see heterogeneous networks, whether it's, sort of NTN and YSUN or LoRa or whatever. So having standardized, interoperable technology, particularly for higher layers, so security, cybersecurity, device authentication, for example, application layer protocols. So, we have customers or members using lightweight M2M, for example, over a YSUN network. So you can mix and match technologies. That becomes very important.
Right. Okay. So Francesco, in terms of NTN and 5G and IoT, in terms of integration and opportunities, you see, critical mass building there?
I do. And just relying on what has been said by Phil, I think that going into standardization and starting using these chipsets, which are built-in devices, should allow us, when I say allow us, allow the industry using IoT to easy access the terrestrial networks, integrate with 5G. By doing that, what happens? We increase the number of potential use case, and I would like to highlight that if I give you a device which has no application, nobody will use it. But the moment we start developing applications on this device, it becomes interesting. And going back to the price point is the value that the customer accepts to pay for. If I give you something which is a life-saving device and you need it, you will pay the money that you need for it. While if I give you a device which has no value for you, you can put it in the desk and that is it. So what I'm trying to say here is that the whole economy of this industry is based on what we give to the customers. So more customers we have, more people can develop. Easier it is if we have a standardization. Easier it will be for us to find investors who will get return over investment. So it's a chain which has to close. And if we start working individually, okay, I have the best solution, but who's going to invest on my solution if they don't believe in what I'm doing? So working together will make, I would say, that move towards adoption by the world outside our industry of what we're proposing. It looks very strange what I'm saying. It looks like, very, very philosophic thinking, but at the end, it's the user who pays for it. And if he doesn't find the value, he's not interested. So.
Yeah, I think from some of our research, we sort of see that sort of cellular IoT is about sort of 2 to 3 times sort of cheaper than satellite. And that clearly means that'll push people because everyone's got to run a business and make a profit. But I think in terms of what Elon Musk and SpaceX and Starlink's trying to aspire to is really bring down that cost of connectivity. Do you think they'll be able to really push it down to that level? Phil, what are your thoughts?
That's a good question. I'm not sure I know the answer to it. Can I sort of divert that question a little bit?
Sure.
Right. So you mentioned AI in your discussion. So one of the things we're definitely seeing is, take a smart meter network, take Tokyo. Tokyo has 29 million smart meters that are currently doing 15-minute data. So even if it's a very small amount, that is a huge amount of data aggregation. So if you start putting the intelligence down to the edge, and we're seeing smart meters with AI built into them, then you can reduce that amount of data. So we're seeing applications where edge computing, meshes of nodes at the edge are doing the processing, so you don't actually need so much data aggregation, and you don't need the latency of the round trip that you would do in other environments. So it's not really answering your question, but it's sort of showing that there are alternatives to passing huge amounts of data on a backhaul network.
Right. So Matthew, I mean, perhaps, given your spectrum or licensing background, we're going to probe this. So in terms of sort of flux density, I think there's a bit of a sort of debate going on in the satellite industry where you've got these LEO satellites, and above them you've got the geostationary satellites, and where they're transmitting down to especially gateways on the ground, there's been concerns about sort of flux density and making sure that the geostationary signals can get through to the gateways on the ground. Do you see that as a big issue? I mean, some of that legislation was brought in, I think, sort of 2001. Is it antiquated? Is flux density in terms of the strength of the signal getting to the ground from GEOs versus LEOs? I mean, I think some of these LEO operators want to open up the spectrum and allow more sharing. Is that viable? What are your thoughts?
Well, absolutely. A lot of the centre of the regulatory debate, the ITU and regionally, is on EPFD limits. And there have been efforts by SpaceX and the like to get lower or higher or exemptions at the FCC vis-a-vis geo protections. In terms of getting into the technical details, probably a bit outside, a bit more into the engineering side of things. I'm a lawyer, so. But I think that at the WRC that will play out for sure. Again, under a dedicated agenda item, for sure.
I just want to say something. I've seen interference from LEO to GEO, but I haven't seen GEO interfering with LEO so far. And why? Because LEO satellites can reconfigure to a new frequency because they're modern, they're different, so they can configure to a new frequency or a new beam or something like that. While the GEO satellite, it's fixed, it's there. And it looks very strange, but to geolocalize these signals is very difficult. So I think there's a lot to be done with the industry.
Very good. I've got a few more questions, but if there's any questions from the audience for our esteemed panel, we'll take the pressure off me for a couple of minutes. So please introduce yourself and the company you work for.
Renato.
So Renato Goodfellow, Commercis. Building, Jake, on your reference to power flux density and looking at that balance between compliance and commercialization, as we go from originally needing 32-meter diameter antennas on the ground for satellite communications to direct-to-device, how do we ensure we don't terminate the user's lifespan too early?
In terms of actual human being. Well, I don't think there's a big concern there. I think there's certainly debates about the gateways and so forth, but there's always been paranoia about sort of RF signal strengths with base stations. We've seen that issue gone away, even Wi-Fi access point. But certainly it's a big issue we're seeing in Washington, D.C. as some stakeholders try and sort of release and get those assessments reassessed. But anyway, yes, it always brings me back to sort of back to the future, power flux density. Type sort of things. Francesco, in terms of teleports using gateways, we're obviously using SLKA band. What do you see in terms of the opportunities for optical links? I think Andy touched upon it, but I'd like to get your view.
Well, I think that we will move to that direction because I think the KU band sooner or later will disappear for other users. So the industry has to move to new technologies. Who's going to pay for it? It's again the same question I said early on. Having optical links towards, I call them the feeder links, ground to spacecraft, it's not a problem. Having return links from the spacecraft to the users is going to be more difficult. Why? Because the cost of terminals today is very expensive. A 1 meter optical dish with all the redundant equipment, we're talking about 1 to 3 million, depending where you buy it from. When I buy a KU band antenna, 3.8 meter with a 700 watt HPA, I'm referring to about 250, 300K. So yes, we will move into that direction. Yes, we will have to move. When? It will take time. And for sure, governments have a role to play, because as we're launching scientific satellite, Earth observation satellites and stuff like that, by having the governments investing in these new technologies will help the industry to develop and improve, and therefore bring down the cost, which can then be adopted by commercial companies.
Right. Any other views on optical links, Matthew? It's not RFF, you don't touch it.
I think Francesco covered most of it.
Okay, very good, very good. Phil, I mean, maybe I should apologize. Should I have had YSUN on my slides? I mean, what is YSUN Alliance trying to do in the space tech sector? What can be done to integrate opportunities for the YSUN Alliance and your stakeholders in space tech?
So I think, as I mentioned, predominantly it's remote access at the moment. So where we're not in the area of mobiles.
But then, cities and...
But yeah, so, I mean, so we're not in the cellular area. But however, there are also situations where you have natural disasters where the cellular network either disappears immediately, or you don't get power for 3 days, so the towers go down. And in which case, using satellite is a good backup strategy for that. So we're doing, YSUN is pretty active within Japan, and there's activity going on disaster recovery at the moment, how to manage that. Another area that we're working in is also with drones. So using drones for monitoring places that are hard to access. So direct connectivity in that situation, which you mentioned earlier as well, is an important area.
Yes, I mean, so high altitude platforms is starting to get some momentum. I mean, I'm based in Singapore, and Japan, as you say, there's, I think, Space Compass, they're trying to build, I think it's Alto is another one. In terms of, you see opportunities with sort of HAPS or emergency scenarios? I mean,
yeah, there's the emergency scenarios. The other area you mentioned is maritime, which is another area. So there's quite a lot of standardization activity going on in sort of within the maritime communications, certainly in-ship and container communication. So containers are actually a very difficult object to use radio with. So having a wireless mesh using surface wave, for example, and then having a communication to a satellite is a good way of monitoring not only container condition, but, if piracy is another area there.
Right, true. I think moving the discussion on, I mean, I think we sort of touched upon in terms of opportunities, data centers. I mean, it just seems everyone's building more and more data centers. Went to one session at Asia Tech in Singapore, and the data center operator said they have to have at least 4 different comm links, fiber optic comm links, ideally from 4 different providers into the actual data center, just to get that sort of 4 nines, if not 5, if not 6 nines reliability. In terms of using satellites, I mean, I think there's momentum there. I mean, Kuiper belts, obviously they're doing data centers. Thoughts in terms of provisioning for data centers, Matthew?
Well, I think wherever there's a demand for capacity, there would be a demand for satellites, particularly as a resilient network fallback. So I think with the transformation that we're seeing with AI and the billions of dollars being invested in data centers globally, I think absolutely I'd be very surprised if there wasn't an opportunity for satellite to step in, particularly given the remote locations where a lot of these data centers are probably going to be expanded into.
Francesco?
I think that the idea is very good. The problem is the limitation of throughput that you have through satellites. If you're having data centers which have a huge demand of gigabytes, the satellite today, yes, we can get up to probably 10 gigabyte, 20, 30 gigabyte. You're using the whole satellite. And the other problem you have is in terms of latency. If you're using a high geo satellite, you have 600 milliseconds, which for some application doesn't work. Going to LEO satellites, if I look at Starlink constellation, depending where the satellites are, how many they are, or how they've been used, you can go from 0 to 200. So it's really how much throughput they need. In my past experience, when we were in these cases, yeah, we would define with the user the minimum bandwidth that they need. So you say, this is the minimum megabits I'm going to give you, guaranteed, and you pay for it. But I was never able to provide the full throughput.
Very good. I think it's my last question. I'm going to go down the whole line here. So my question is, what will the satellite landscape look in 5 to 7 years from now? Francesco, you seem to be a bit skeptical about NTN. So, but anyway, we'll come to you last. But how do you sort of look in the future? You've taken over my job, Matthew. You're doing the forecast. You've thrown away my forecast. You're doing your own. How do you see the landscape look in sort of 5 to 7 years' time?
Well, I think the NTN marks a dramatic shift in industry and what satellite has been traditionally seen as. Satellite's been traditionally seen as a fallback, a sort of exclusive reserve for specialist applications. But I think hopefully in 5 years' time, as we're already seeing, the interoperability of devices where satellite is essentially a native part of the 5G ecosystem. So I'm hoping that through the 3GP work programs, satellite will be firmly recognized, not only for direct-to-cell, but also IoT, with narrowband IoT. And I think that would be fantastic for the industry as well. But there are challenges. As touched upon, there's a lot to play for. The convergence of satellite and terrestrial blurs the historical lines, as it were, from a regulatory perspective, between terrestrial and satellite, which for regulators creates a lot of challenges, whether it's license fees, dynamic access to spectrum. So speaking as a regulatory expert, there's a lot of problems to be solved. But personally, I think it's very exciting, and I hope that it works in 5 to 10 years' time.
Okay, a bit positive there. Phil?
So I think if the pricing is right for the appropriate IoT applications, then it will grow well. That's a very short answer, right. I think. But I mean, and as we've talked about before, there are certainly remote application areas where satellite is the solution to the problem.
Right. Do you remember about 40 years ago, it used to be a TV program on a Saturday afternoon called The Price is Right?
Yes.
So, Francesco, what are your thoughts?
I think that with the geopolitical situation that we have these days around the world, I think satellite, despite what I just said earlier on, will have a role to play, especially if governments start considering how to protect the sovereignty of each country. So this will certainly enable the industry and us to survive a few more years. Again, price has to be right. We need to have the right technology. We have to have scalability. We need to be able to have APIs so that people can easily interface with what we're doing. Standardization is a must, if not, unless somebody has a magic technology, I think standardization is very important. And very important is also the fact that we need to see how we can reduce the barrier to enter into the satellite business. So device to satellite is great, but if I'm using devices today, what is the total throughput I'm getting? For some application, it's perfect. Measurements and stuff like that is okay. But if I have to communicate a file, how much time does it take to upload or download that file? So these are things that need to be solved. Probably with AI, things will go much faster than what we've done in the last 20 to 30 years. See?
Right, right. Any last questions from the audience? The lady in front.
Hello, Rim Feliashi from NSG. I have a question regarding IoT over satellites. So you talked quite a lot about, the S-band, the L-band, when we talk about 3GPP, and you mentioned also briefly about the higher frequencies that are standardized, but the ecosystem is not ready, and there is a big cost associated with maturing the technology there, and who is going to pay that cost? So as a follow-up question maybe to that point, what could be incentives given the, the difficulty of accessing lower band frequencies? What could be incentives to develop the higher frequencies and challenges as well, except financial?
Matthew, you want to have a go at that first?
Yeah, so I think, well, from an operational perspective, moving into the higher frequencies is industry is perhaps moving in the other direction in terms of the LNS. But I think that, as we touched upon standards, international standards, creating a playing field for operators to be able to coexist in these higher frequency bands under a pragmatic basis would be a place to start, at least from the regulatory perspective. So harmonisation, I would say, is absolutely key from my perspective.
Any other thoughts?
I think that going to higher frequency will give a much bigger throughput. I think that we're going to go from tens of giga to hundreds of gigas. So this is an incentive to move toward higher frequencies. I see that as an incentive.
Good. I think there was another question.
Also down there.
Yes.
Hi, Lawrence Russell, Data Center Dynamics. So this is actually more of a question for Jake on your presentation earlier. You had quite a fair bit about Chinese companies there, and I found that very interesting. Usually people sort of skirt over that. I would love a little bit more color on what you're seeing out of there right now, and perhaps more specifically if you think that in Southeast Asia, procurers might be more comfortable with Chinese services versus Western alternatives. I'd love to hear from the panel as well.
Sure, yes. We have a whole report looking at the Chinese ecosystem. We might have pulled out some insights for you. I think you're a portal, a magazine, so we can pull out some out as a journalist. We can help on that front. Yeah, I mean, there is certainly got sort of SpaceL, and then you got Guowang, both with aspirations for sort of, tens to, if not sort of 15,000 satellites. I think the challenge is their business model. They're a little bit being reactive to what's obviously been coming out of the States. But the philosophy in China is they've done a tremendous job in terms of the mobile operators, China Mobile, China Unicom, China Telecom, in building up from 4G into 5G coverage, being very proactive on their front. They've now got a sort of vendor ecosystem, which again is very proactive. So therefore, in terms of do they need satellite, do they need sort of satellite service within the domestic market, officially the answer was no. But that has now been shifting over the last couple of years. And certain vendors more proactive and to support that. ZTE is very proactive. Huawei is sort of holding back. But they'll need that domestic market to be successful. I think if you look at what SpaceX has done with Starlink, it's built up its momentum on the North American market, the US market, and then spread its wings into other parts of the world. So I think they'll have to do something similar. They will need an internal base. And I think, to be honest, China's a very big place, and there are definitely communities and scenarios of usage where they could have better access to sort of just reliable space comms type sort of services. Do you have a second half of your question?
In Southeast Asia.
Oh, Southeast Asia. The answer is yes. I mean, I think there are certain markets which are more aligned with the West, others more neutral. So like sort of Singapore does align more with Western sort of economies, but it also tries to maintain relationships with China. Malaysia's more in the middle, a bit more neutral. So there is interest, and I think these economies are growing, but disposable income is still a challenge. So I think they'll be interested in some of these satellite operators. But I think the issue is when do they actually become fully commercial will be the biggest issue. because you can have the designs, but then you need to get the satellites into orbit, and ideally you need sort of reusable launch systems to be able to get those satellites up there. They've been doing some prototypes, but then way behind, obviously, what SpaceX has already achieved. So there's a lot where obviously Starlink can consume and build on that opportunity. Any other questions?
We can
Gentleman
take
behind.
one more. Who's
Guess gentleman in the middle.
all right? We're feed 2 in.
While going there, there's another question about the terminals. As these are going to be built by Chinese companies, they're going to be proprietary to Chinese technology. Is the Western world or these countries going to adopt those terminals? That's another question.
True. Gentleman over there, please state your name.
I end up with the mic anyway. My name's Alexander Reed. I'm from Cambridge Consultants. I'm interested in the commercialization of IoT. So I think, Jake, you mentioned just vehicle IoT as kind of one avenue. In that type of situation where you're kind of selling to the consumer, who's expected to foot the bill for that? Is it expected that you think the manufacturer would include it as like a perk of the vehicle, or are we expecting some kind of subscription service or something for access to these IoT satellites?
For the automotive?
Just as an example, I went with automotive, yeah.
Right, okay. I mean, right now, in terms of most vehicles, when you purchase the vehicle, you get a telematic control unit installed. Often you sort of get 1 or 2 years of free access on a plan which allows sort of more entertainment type services. But crucially, it's the automotive car brand that really wants access to the telematic control unit because they want to sort of monitor the overall performance of the car. So that's been the current sort of business model. And as they sort of shift their focus to what satellite can provide, I think, yes, there's some question marks about the business model. I think we see with NTN Mobile, if you're on a sort of top tier plan, you then sort of get grandfathered into sort of satellite NTN mobile access. So we could perhaps see something like that, where you're a premium user and you've got your vehicle, you can then get that sort of NTN access to your vehicle as well for more remote locations. But there's some question marks about some of these business models, which can't be avoided.
We can take one more question. Where's...
Michael Lukin from TTP. My question is related to the previous one. This is about business models and business case for IoT from satellites. So, Jake, you've shown graphs of connectivity, number of connectivity connections via satellites. But how about the revenue? So basically, if we go through the list of you've shown, OQ Technologies, Satelliot, Lacuna, and so on, they've been around for quite a while, but I'm not sure if they are still yet profitable. And EchoStar Mobile in Europe, they have their own spectrum. They started using the LoRaWAN. Do they make money on this? So I'm just questioning, where's that higher value IoT application? Is that going to be defense?
Yes, I think in some of the services being currently offered, they are very low margin. I think that, as I say, they're competing against some of the terrestrial players as the alternative to competing technology. It is, I think, in terms of getting sort of greater capacity, greater throughput, will start to improve the overall profitability of the service. But of course, there is also those competitive pressures. So I sort of show one chart sort of showing the average revenue per connection. And I think that's sort of Viasat at the highest, around sort of $12. And the others are much closer, sort of $2 or $3. But a lot of them are built up on that business model of not just connecting tens or hundreds, but several thousands of devices. And they also activate and deactivate devices. So you have an over sort of pot of capacity as an end user, as a company, which you can then reallocate. But yes, it is very competitive at this moment, and they need to improve their overall sort of overall profitability of the actual service, for sure.